In this video, we will work on solving trigonometric equations. For these examples, all solutions are in the interval of 0 to 2 pi or 0 to 360 degrees. In example A, we isolate sine by dividing by 2. Then we rewrite it in inverse notation to get theta by itself. And now we think about sine inverse of the ratio negative root 2 over 2 gives what angle on the interval of 0 to 2 pi. And we know in quadrant 3 and quadrant 4, sine is negative, and the ratio negative root 2 over 2 correlates to the angle 5 pi over 4 and 7 pi over 4 on the interval of 0 to 2 pi or 0 to 360 degrees. Next example. Here we divide by 2 to isolate cosine theta. Then we rewrite in inverse notation to get theta by itself. And we read this as cosine inverse of the ratio root 3 over 2 gives what angle theta. And between 0 and 2 pi on the unit circle, that root 3 over 2 correlates to the angles pi over 6 and 11 pi over 6. In this example, we get a little more challenging, but not too bad. First, recognize that sine 2t can be written as 2 sine t times cosine t. Then we can factor a cosine t from both of them. This leaves us with a nice factored form of cosine t times 16 sine t minus 13 equal to 0. So we can then split this up into two equations and solve cosine t equals 0 and 16 sine t minus 13 equals 0. For cosine t equals 0, we write in inverse notation to get t by itself. And cosine inverse of 0 is at angles pi over 2 and 3 pi over 2, or 90 degrees and 270 degrees. For the equation 16 sine t minus 13 equal to 0, isolating the sine t by adding 13 to both sides, then dividing both sides by 16. We get sine t equals 13 over 16. Then writing in inverse notation, we have t equals sine inverse of the ratio 13 over 16. Here's where it can get a little confusing, but hopefully makes sense. Entering sine inverse of 13 over 16 gives us the answer 0.9484 radians. Which is equivalent to 54.34 degrees. These results are specific to the answer in quadrant 1. But on the interval 0 to 2 pi, or 0 to 360 degrees, the ratio 13/16 also corresponds to an angle in quadrant 2. To find that answer, we simply take pi and subtract our answer from 0.9484 in radians, or 180 degrees minus 54.34 degrees. In this example, we can relate this to a quadratic equation. Let's substitute u in for cos t to see this. Now that this looks like a quadratic equation, we can use the quadratic formula or factor to solve. I will factor by grouping. So look for factors of constant times leading coefficient that adds up to middle terms coefficient. So factors of 2 that add up to -3, which we know is -1 and -2. So split up middle terms as these factors, so -u and -2u. Then we group the terms and factor a u out from the first group, then a -1 from the second group. Now we can factor 2u minus 1 out from the left side, and we have 2u minus 1 times u minus 1 equal to 0. And we can solve equations 2u minus 1 equals 0 and u minus 1 equals 0, starting with 2u minus 1 equals 0. Isolate u by adding 1 to both sides and dividing by 2. And remember, u is really cosine t, so we are really solving cosine t equal to 1/2. Getting t by itself, we have t equal cosine inverse of 1/2. And on the interval of 0 to 2 pi, or 0 to 360 degrees, the angle t will be pi over 3 and 5 pi over 3, or 60 and 300 degrees. Now we solve u minus 1 equal to 0. So u minus 1, which really is cosine t, equals 1. So t is cosine inverse of 1, which happens at 0 and 2 pi, or 0 and 360 degrees. Now let's do another fun example. So in this example, we notice the cosine 2x on the left side and the sine squared x on the right. It may be easier to use an identity on cosine 2x, namely 1 minus 2 sine squared. So let us do that. Plugging in our identity, now we have an equation with just sine squared in it, and we can manipulate both sides to get it by itself. Now that we have sine squared x by itself, we can use the square root property to get sine x by itself. Sine x equals plus or minus 1 over root 6, which we can convert to root 6 over 6 if we want. But I'm actually going to just leave it as is. Now we split it into two equations. Sine x equals negative 1 over root 6, and sine x equals 1 over root 6. Starting with sine x equals negative 1 over root 6, we know that that happens in quadrant 4 and quadrant 3 since sine is negative there. For the result in quadrant 4, we input sine inverse of negative 1 over root 6, and we get out a negative number. But we want to have answers from 0 to 2 pi. To get that, we simply add 2 pi radians, and we get 5.86 radians, which is in our desired interval. For the answer in quadrant 3, again, since we want a result to be between 0 and 2 pi, we take pi and subtract sine inverse of negative 1 over root 6. So we get about 3.56 radians for the answer in quadrant 3. In degrees, this is equal to about 204 degrees. For x equals sine inverse of 1 over root 6 on 0 to 2 pi, There are solutions in quadrant 1 and quadrant 2, since this is where sine is positive. Sine inverse of 1 over root 6 gives our desired result in quadrant 1 of 0.42 radians, or 24 degrees. To get the answer for quadrant 2, we take pi and subtract sine inverse of 1 over root 6, and we get 2.72 radians, or 155.91 degrees. Now we will do an example for when we aren't dealing with right triangles and we want to figure some stuff out. We will use the law of sines or law of cosines described on the left. In this example, we will use the law of sines to solve this triangle. So first, let's draw a diagram with our given information. For angle B, we can find that simply by 180 minus 40 minus 65, which equals 95 degrees. Now we use the given proportions to help solve. Let's use sine A over A equal to sine B over B to find what A equals. Solve for A, we use the cross product and then divide by sine 95 degrees to get A by itself. plugging this in our calculator, we get A is about 14.84. Similar process to find C. Set sine B over B equal to sine C over C. Then cross multiply and divide to get C by itself. And we get C is about 20.92. In this next example, we will use the law of cosines to solve for the angle A. First, let's label our known values A, B, and C respectively. Then we can see from the left that we use the first formula to help solve. So plug in our known values. A equals 19, B equals 25, and C equals 11. Then we simplify and manipulate the equation to get cosine of A by itself. Now that we have cosine A by itself, we get it in inverse notation. So angle A is equal to cosine inverse of 385 over 500. Using our calculator in radian mode, we evaluate and get about 0.7954 radians or 45.573